When we are multiplying and dividing with exponents, if we understand how they work, we can take some shortcuts on how we can put these expressions together. If I have 5 squared, really it's 5 times 5. So I'm going to rewrite it as multiplication so that I can see exactly what I'm dealing with, because I really understand multiplication. And if I have 5 to the power 4, I'm going to write 5 times 5 times 5 times 5. So really what we have here is, since there's an implied multiply here, what we really have is just all 5s being connected by multiplication. Well, if that's the case, then I can just count up the 5s and rewrite it with an exponent. So my multiplier is 5, and I can count 1, 2, 3, 4, 5, 6 times I use 5, so my exponent is 6. Now there's a much easier way to do this, because since this is connected with multiplication, and remember that we can only connect powers with times, we cannot connect powers with plus. But since we can connect powers with times, really we can just say that our multiplier is the same in both cases. This is counting the multiplication, this is counting the multiplication of the same thing, so we can count them together to get 4 plus 2 plus 4 is 6. So we can do the same thing here. So I'm going to write it out first, but I have 3 times 3 times 3 times 3 times 3. And I can rewrite 3 to the 7 as 3 times 3 times 3 times 3 times 3 times 3 times 3. And here I end up with 3 to the power 5. And since they're the same multiplier and they're all connected by multiplication, I'm just really connecting or counting all multiplication of the same number. Well, I can count 5 here and I can count 7 here. Well, I should just count those together. And if I count that all up, yeah, I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 3's being multiplied. And so we can come up with this general rule then. If I'm multiplying and the bases are the same, I can just figure out the new exponent by adding that exponent. So a5 times a7, since it's connected by times, I can just count 5 a's and 7 more a's, and I can get 12 a's. So anytime I have multiply and exponents, I can count up the exponent by adding the exponents together. This only works for multiplication because remember that powers and plus are not compatible, so there's nothing I can do here. So this has to stay a5 plus a7. Okay, we cannot connect powers with plus. So make that a little bit clearer. We cannot connect powers with plus or minus. But powers can be connected with division because times and divides share the same rule. So if I can do it with times, I should be able to do it with divide. So what would it look like? I have a multiplied 5 times, or 5 multipliers of a, and I have 3 divide by a's on the bottom. Top is times, bottom is divide. Well, I know that a times a and a divide a will undo each other. A times a and a divide a will undo each other. Times a, divide a, undo each other, and when I undo multiplication and division, I'm left with 1. So in the end, I end up with a squared. I'm going to count. There's 2 a's left with multiply over 1, or I can just write this as a squared. And the shortcut then would be, since the divide count against the multiplication, I can subtract. And this would be equal to 5 minus 3. That would also give us the a squared. And again, if we're not sure, we can always just write it out. We can see, we know our times and divide rules, and we can see that if we use our times and divide rules, we end up with a squared. Lastly, here we have 3, we have a in the denominator 5 times. Well, our times and divide, we can't really do anything with this, so really we can just leave it as is. So we should just leave this as 3 over a to the 5. Now, some people may know this rule, and we can actually make this a to the negative 5. And if you know that rule, that's fine. If you don't, one way we can think of it is, if a positive exponent counts multiplication, a negative exponent actually counts division. And so we can actually write the divide in the denominator with a negative exponent. And we won't really get into that, but that's something that we could do.